In this lesson, we're going to continue to graph linear inequalities, but now we're also going to be completing a table to find the minimum and maximum values for those graphs. You'll notice in number 3 that we have 3 different inequalities. So I'm going to graph each one separately. My first one is x is greater than or equal to 1, which is a vertical line. So I'm going to go to 1 and draw a vertical line. And then I'll shade where x is greater than or equal to 1. Which, since it's x is greater than, that's going this way. So here's my shading here. Everything green. My second line then is y is greater than or equal to 0. So for that one, that's a horizontal line, which happens to be at 0. So that's this line on the axis. And it's where y is going greater than, so I'm going to shade above the line. I'm going to use yellow for this one. So it's all above that line. My third line then, I have to actually get y by itself. So I'm going to do that in order to graph it. I'd minus 2x from both sides. And I have y is less than or equal to negative 2x plus 6. So as I go to graph this, I'm going to go to 6 on the x-axis, or on the y-axis, excuse me. Make sure that's on this line. Some people like to put on their green line accidentally because it's drawn there, but that's on 1, remember, that's the one we graphed ourselves. So I go to 6, and my slope is negative 2 over 1. So I would go down to right 1. Down to right 1, all the way through. These graphs you're really going to want to use straight edge on. I'm not going to do that because I only have so many hands right now. But that was pretty good. So there is my line, y is less than or equal to negative 2x plus 6. Now since y is less than, I would shade over here. So when I go to do that, I'm going to shade on this side of the line. So now my answer is where you see green, red, and yellow. Only green, red, and yellow. That's my common shader. Now, this can get really messy, but my graphs always look worse than your guys' on your paper. These just get really messy on the smartboard. So my common area, I'm going to go ahead and put in blue here, is right here, this triangle. Can you see that shape right there? That's where they all overlap. And you'll notice it's an enclosed area. So it's a common area right here. And we're going to do some word problems where we're looking to find this later in the week. So you'll see why we're going to do this later, but we have to first learn the graphing so we don't do too much in one day. So now it says down here, once you find the shaded area and vertices. Okay, vertices, what would that mean? Vertices would be all the spots where my lines cross at the intersection. So right here is a vertice, right here, and right here. So that's where two lines crossed to enclose our figure. Those are all our vertices. So if I can name those points, I should. Well, I think I can name this point right here. And you, again, will be able to see this better on your graph because yours won't look as sloppy as mine. But this point right here, hopefully we can see is the point 1, 0. So there's one of my vertices, 1, 0. This point here, then, is 2 to the right, so that's 3, 0. And then this point up here, I had put a dot on it so I can name it for sure. It's 1, 4. And since I had put dots on all those spots, I knew where those points were. They happened at intersections. They weren't happening at fractions or decimals. So then it says, once you find the shaded area and vertices, we want to find the maximum and minimum values for this function. Now don't be scared by the fact that they gave you this function. I'll teach you how to find this later. For right now, it's just going to be given to you, so you're going to leave it like this. So they've moved that right down here into the table. They want us to list our vertices. So the vertices we listed are 1, 0, 3, 0, and 1, 4. And after you do that, all you need to do now is actually plug those x and y values from your vertices into this function that you were given. And again, don't worry about where it came from. We'll learn that later. For now, we're just going to be given one. So in this one, I would say, okay, my x is 1. So 3 times 1 plus 0. 3 times 1 plus 0 would be 3. I'd have 3 times 3 plus 0, so 9. And I'd have 3 times 1 plus 4, so 7. And that's me filling out the table. So now they're asking where our maximum and minimum values are. Our maximum and minimum values are going to come from right here. These values right here. So my maximum value is 9, right? That's the biggest number we came up with, and that occurs at the ordered pair 3, 0. My minimum value, so my lowest number that I got, was 3, and that occurs at 1, 0. And when we start doing word problems, you'll see where this is going to come into play. So hopefully that made sense for you. That's an example of one that's bounded, meaning all the shade area is enclosed by a figure. Number 4 now, you'll see we have 3 different inequalities. So I'm going to want you to pause the video and get y by itself in all of those for me, please. Okay, so now you got y by itself. Hopefully you got, I'm going to just color code these. The green one would be y is greater than or equal to negative 2x plus 3. The one I'm got in blue here is going to be y is less than or equal to 1/3 x plus 3. And then this one right here would be y is less than or equal to negative 2x plus 10. So there are my 3 lines I need to graph. I'm going to go ahead and graph them with the colors I chose here. So you'll see we have quite a big graph here. I'm going to go with the green one. So I'm going to start at 3, and then my slope is negative 2, so down to right 1. And I like to go all the way through my graph. You don't have to because you guys will use a straight edge, but since I don't use a straight edge up here, it makes my lines a little better. So I'm going to connect the dots. And then it says y is greater than this number. So greater than would be where y is going greater than. So that's all this direction. Okay. My next line then is my one in blue. So I'm going to start at 3 again, same spot actually. And my slope is 1/3, so I'd go up 1, right 3. Up 1, right 3, down 1, left 3. Connect those dots. And that one says y is less than, so I'm coming down here where y is less than. And I'm going to shade everything down here. So there's my second line. My third one then in red would start at 10, so way up here, and my slope is negative 2, down to right 1. Now hopefully you recognized that you had 2 lines that had a negative slope, negative 2 slope, so you should be expecting those lines to be parallel. So as I connect these dots, and this line is where y is less than, so that's going to be over here. I'm going to have to color over that arrow. So I'm going to come in here and do everything this way. There's my shading. So now hopefully you're looking right now for where blue, red, and green cross. That's where I'm looking to have my common area. And I'm going to go right here and put it in purple. It's this enclosed area right here. And then notice what happens down here. This is called unbounded. So this area right here is unbounded. That's the name for that. And that's just saying it's not enclosed by another figure. So we still have vertices for this line. They occur right here and right here. And you'll notice if you look at your table, I only gave you 2 spots for it, so that kind of makes sense, right? So if you look here and name these ordered pairs, this first ordered pair right here is 0, 3, and it's really hard to see that on mine, but I know on your graphs it'll look a lot neater, so you'll be able to see that. And then hopefully you can see the second ordered pair is 3, 4. So when I come down to my table, I'm going to plug those in. 3, 0, oops, sorry, backwards. How about 0, 3? 0, 3, and 3, 4. And then again, they gave us this function. They're saying it's a function for x and y. So they're just giving the variables there, and here it is, 5x plus 4y. So there we go. And I'm going to substitute those in for x and y. So 5 times 0 plus 4 times 3, that would give me 12. 5 times 3 plus 4 times 4 gives me 31. Now, my maximum value, so my biggest number, is 31, right? So my maximum value, I would say, is 31, and that happens at 3, 4. Your minimum value, you would maybe think it's 12, except remember you have this area that's unbounded. So minimum is your lowest value as you're going down. This keeps going. So my lowest value is actually negative infinity. So we're going to say none. It's unbounded. If you wanted to say that your minimum value is at negative infinity, that would be an appropriate answer also. But I won't require that. So think of it with our domain and range. It kind of makes sense that it would keep going forever down all the way here. So I don't have a minimum value for this because the minimum value is negative infinity, and I'm not going to be able to apply that to anything besides knowing that it doesn't stop. There we go. That's all we got for today.